Hello friends, once again welcome back to this physics class, and today, as it is very clearly mentioned on the board, we are going to discuss some good problems, that is exercise, and that is meant for JEE advanced pattern. Fine. So JEE, obviously it's a final you can say exam, and by appearing in this exam, if you are scoring very good in JEE mains, if you are clearing that cut limit cutout, so you can say yes, now I am planning to appear in this, and by scoring very good rank you may land in any of the IIT campus. So the first option should be try to score minimum 300 marks, and for that there is a video in which I discussed a strategy for how you can score minimum 100 marks in physics. Fine. So by opting that strategy, by adopting that thing, you may understand that this is not as difficult to score 100 marks in physics in JEE mains. So if you score around 300 in JEE mains, obviously you will get the ticket to appear in this JEE advanced pattern, and if you perform well in this, and obviously I know many of you may perform, will perform. So definitely IIT Kanpur, IIT Mumbai, IIT Chennai, something like that is going to be your next home. So best of luck for that. Let's start this discussion. So this is the first chapter of electric charges and fields. I hope till now you must have revised various concepts and basic formulae that are the part of this chapter. So that's why we are picking advanced pattern question. One more thing that I would like to mention on the basis of my own experience. Fine, on the basis of the experience as a teacher and also as a part of the IIT Delhi student. Nothing is difficult for this exam. If you are preparing well, if you are preparing with focus, definitely you will click in this exam. So once again, best of luck. Let's start this discussion. Now, here comes the first beautiful question. And what is that question? In JEE Advanced, because as such there is no repetition of the question, every question is like a new problem, a new question based on new thinking, and mainly on the application part. So over here, just try to understand what exactly is mentioned in this problem. First, with proper discussion, I will elaborate you the problem, and then I will provide you the proper step-by-step solution. See, in these questions or in this session, my point is not to provide you the solution of these problems, not at all. My intention is to develop a habit in you, inculcate a habit, professional approach in you, how to read, how to think, how to visualize questions for these competitive exams. Unless and until you are unable to understand the problem, even if I am explaining 1000 problem to you, you are not going to get success. So step by step I am elaborating the problem, I am telling you where you have to think differently and then how you can formulate the solution. So over here the question is, charges Q, 2Q and 4Q, three different charges are uniformly distributed in three dielectric solid sphere. Now catch point starts. Dielectric solid spheres. So while reading the question for JEE advanced pattern, obviously this strategy is also applicable for JEE mains, but for JEE advanced it is utmost important. It is not conducting material solid sphere, not metallic sphere, it is not non-conducting, but it is dielectric, and the properties of dielectrics are not as similar as of insulators. Fine, that much knowledge now I am sure you must have. So 1, 2 and 3, and here is the diagram of these spheres. One is of r by 2, another is of radius r, and another is of radius 2r. So let me complete few terms over here, which is as such not given in the question, but while solving these problems in examination hall, you have to use rough sheets, and there you have to perform this rough work. So, this is as per the question is 2R. This is as per the question simply R. This is something which is required in examination hall. You have to do these type of things on rough sheet provided by the examination body, that is Indian Institute of Technology. And then this radius is R by 2. Fine. So, now the diagrams are complete. Again and again you need not to read the problems. One more thing you can add over here, that is charge Q, charge 2Q and charge 4Q. Fine. Then if magnitude of electric fields at point P at a distance r from the center of a sphere 1, 2 and 3 are E1, E2 and E3, then find the relation in E1, E2 and E3. Fine. It's like that. In this question the IIT is giving you some basic material and you have to prepare a final recipe. Why? As I added R, 2R, 4Q, 2Q and Q, now again what you will have to do? With sphere 1 electric field E1, with sphere 2 electric field E2, with sphere 3 electric field E3, and at point P. So, where is point P? In the diagram it is not given. So, again rough sheet, rough work. So, here for this small sphere this is point P. Fine. For this second sphere this is point P, and for this sphere this is point P. What exactly you can conclude about this point? Now, you can say that for a small sphere point P is outside of dielectric material sphere, visible. For this sphere point P is at the circumference, and for this bigger sphere point P is within the solid sphere. Fine. And beautiful part is that from the center till this point the distance every time is equal as R, R and R. See the time taken by the question to translate itself, to visualize itself. That is why JEE questions are slightly difficult, otherwise they are not asking anything which is difficult over here. Now, let me also introduce E1, E2, E3. So, E1 is for this small sphere, that is E1, E2 is for this, that is E2, and E3 for this. So, now finally I translated the question. There is a proper makeup and let us start this fancy dress competition. Fine. Now, we have to basically find out what is the relation between E1, E2 and E3. So, rather than asking like this, they twisted the solutions also. Confusing. E1 is greater than E2 is greater than E3. Okay. E2 is greater than E1 and so on. E3 is greater than. So, now mix and match type of things. No need to take the look of the options for the time being. Problem is, you cannot get any positive outcome by just looking into these options. You have to work out. Only after solving you will get the proper solution which one is correct. Otherwise, you keep on watching these options, they will keep on watching you. Finish. So, let us start the step by step approach of this solution. At this space the question is going to be present with you, the diagram I completed, that is also with you. Let us start this solution over here. Fine. And this is also going to be the part of your video. Over here whatever I am going to provide you, that is also going to be the part of your solution. In this entire discussion I will use K is equal to 1 upon 4 pi epsilon naught. So, wherever I have to write down 1 upon 4 pi epsilon naught, so in order to save the time and space I will use K. That is why I declared this function initially. Fine. So, now let us start for first sphere, that is going to be E1. So, E1 is equal to K Q over R square. Now, see the beauty of these questions. This is not anyway a difficult formula. It's the basic fundamental formula that you learned on the very first day of your class 12 course starting. Simple, 1 upon 4 pi epsilon naught Q upon R square. Fine. For the second sphere, that is E2. E2 is equal to K, and then the value of charge, that is 2Q over R square. No problem. One is outside and another is at the circumference. Fine. Now, here comes this 1 and this 2. As such, very simple. Let us try to solve it for E3. And here the entire concept checking process will take place. Inside a dielectric material, how the electric field is going to behave. So, I am writing this solution as K Q over 2R square. I am sure this E1 and E2 as such no problem. So, what I can say, at least for E1, E2, E1 is equal to what? 2 times of E2, very clearly visible from here. So, let us finish this entire story and say it is twice of, sorry, E2 is equal to twice of E1. Fine. So, E2 is nothing but 2 times of E1. So, for the time being, these are very good people, they are our friend. So, let us say them goodbye, because now I have to deal with this person. KQ, what is the charge over here? 4Q. The first thing that will create some sort of confusion in your mind, why only Q? Okay, wait for some time. Now, this distance is going to be R, while the total radius is going to be R by 2. So, if I am saying that this point is situated exactly midway from the center, I am sure you will say yes, it is correct. Okay. So, now let me allow to write down this expression over here. E3 is equal to K Q over 2R square. Fine. To prove this point, to give you better understanding, I would like to mention that for, I think I should use a different color, for outside of dielectric, E is equal to KQ upon R square, KQ upon R square. Fine. And at surface it is going to be E is equal to ES into R by capital R. So, this relation we used for understanding of this E3. Now, from here let us start watching which one is the correct option. Fine. So, if you start watching about the correct option, then now things are clear to me. E2 is twice E1, means E2 is greater than E1. So, now if simply you solve only this much, the answer is in front of you and he is saying I am the correct answer, please pick me. E2 is greater than E1. Fine. Is there any other option? No. For the time being, this is just clever approach, but also try to understand. This is E3 is going to be E1 by 2. So, even E1 is greater than E3. So, C is going to be your correct choice. So as such, do you think it was a difficult question? Not at all. Simple question. Fine. Now let's clean this entire portion of the board so that we can start discussing next problem. And the way I explained, because time is not a problem for these competitive exams. It is not required that you solve 100%. You want to score a good rank, that's it. You want to secure a seat in any IIT, that's it. So first ensure that at least that much you are performing. Fine. So now let's move ahead onto the next problem. And in this next problem, what is the question? First try to understand. An electron of mass Me, Me is a symbolic representation of the mass of electron in general, initially at rest, okay, electron is placed on a table, something like that, moves through a certain distance in uniform electric field in time t1. Okay, keep visualizing, keep visualizing. A proton of mass mp, also initially at rest, takes time t2 to move through an equal distance in this uniform electric field. Neglecting the effect of gravity, what is the ratio of time t2 by t1? If you keep on reading the problems of JEE Advanced exam, they are so beautiful. It's just like listening a melody. See the beauty of the problem. One side you have electron, one side you have proton. The basic idea is mass of proton is 1836 times more than the mass of electron. So proton is quite heavier, okay. In the same electric field, both are starting from rest. So if both are starting from rest, you have to find the time period taken by proton and electron to complete a certain distance. So if they are starting from rest, definitely I would like to go back in class 9th for what? Obviously for S is equal to ut plus half at square. Is it like that? Any new formula is applicable? IITs are just trying to check your basic understanding. If the proton or electron is starting from rest, it means this term is going to be 0. So you have to apply only this much formula. That's it. Where is the difficulty? Now step by step, let's try to analyze this situation. Fine. So this is the question. Let me try to solve this question over here. Let me summarize the question in simple terms once again. I have an electron and proton. Fine. Both are in rest. Then they starts moving in external electric field. One more concept that you can revise in your mind. Electric field, positive charge will try to accelerate in the direction of the field. Electron, negatively charged, will try to move opposite to the direction of the electric field. So ultimately we are trying to find out the acceleration of both the particles, because we have to use the formula of class 9th, S is equal to half at square. Fine. So from here, for both particles, electrostatic force Fe is electrostatic force, it is going to be equal to EE. It is not like I am saying electrostatic force for electron or charge of electron. I am saying on a charged particle in an external field, the electrostatic force that will act will be given by this formula. So if from here I am saying for electron, fine, for electron AE is equal to Fe upon Me. AE is equal to Fe upon Me, mass of electron. So obviously you will say that is a very simple formula. Is it like that the JEE advanced questions are so simple? Yes, they are so simple. So now from here for proton AP is equal to Fe. Why I am saying Fe? Because ultimately we are trying to focus on to the electric force, electrostatic force rather, and mass of proton. Fine. So now use this relation, that is S1 is equal to half A E T1 square. Fine. And S2 is equal to half A P T2 square. This is equation number 1, this is equation number 2. Now, what exactly mentioned in this question? Equal distance. Equal distance means S1 and S2 are equal to each other. So if S1 and S2 are equal to each other, then I will use this space for getting the final result. That is going to be AET1 square, yes, is equal to APT2 square. Fine. Now from here I can say T2 upon T1 is equal to, in terms of these accelerations, AE upon AP under root. Obviously square is there, and finally you will get MP upon ME. Fine. So now please go back to the question and try to check which one is the correct option. So as we are moving for this particular solution, so now it is very clearly visible to me. Is it anything difficult in these problems? Not at all. They are very simple. So that's why cracking JEE is very, very easy. Getting admission into any of the IIT is very simple. Getting the tag of IITian inside is very simple, provided your approach is in right direction and your thinking is positive. Fine. So this way I can say that it is not anyway a difficult aspect. Let's move on to the third question. Fine. And in third question, it's again a very beautiful question. Why beautiful? Let me explain you. A charge Q is placed at the center of the line joining two equal charges Q and Q. I'll have to draw the diagram. A charge Q is placed at the center of the line joining two equal charges Q. The system of the three charges will be in equilibrium if Q is equal to. Actually, don't you think these questions, some statement is missing, something like that? They are just trying to force you that you should start thinking in this way. So let me first complete the diagram. A charge Q is placed at the center of the line joining two equal charges capital Q. Fine. So let's allow to draw a diagram over here. Please take a look. This is a line and one charge capital Q is placed at this point, another charge capital Q is placed at this point, and a small charge Q is placed at the center. So let's say this is the center, so a small charge Q is placed over here. Fine. Now equilibrium means the force of attraction or repulsion between these two charges should be equal to force of attraction or repulsion between two charges. So for that particular reason, for that particular solution or situation, you have to find the value of small q in terms of capital Q, and also the sign, whether it is going to be minus capital Q minus q by capital Q plus q by 4 and what not, something like that. So, first you have to ensure this. Now, the basic approach is force between this combination and this combination should be equal. Fine. So, now the diagram is in front of you and the question is also in front of you. Now, I am going to start its solution step by step, and for that I think I should draw the diagram just below this statement, so that whenever you are re-watching this video, you will find yourself in a comfortable situation. Fine. So, capital Q, it is small q. Fine. And let us say the distance between these two charges is capital L. So, it is L by 2 and it is L by 2. Whenever it is required, we will do that. Fine. So, let us try to find the solution. So, as basically I am trying to provide the solution in some details, so that whenever you are watching these videos, you should try to develop your own approach and then try to match with this approach whatever I am explaining you. As Q is at center of the line joining this. So, as Q is at center of these two charges, of these two charges, so F net, fine, that is the net force acting on this combination. So, F net on Q is 0. So, F net on Q is 0, whatever is the magnitude, whatever I am writing, it is for your understanding. Fine. As Q is at center of these two charges, so F net on Q is 0, whatever is the magnitude and sign of Q. Now, this statement is, you may say, slightly confusing. No, not at all. Problem is, imagine a situation over here. Basically, this question is something that I am sure during your class 12th studies you solved at least many times. Fine, this was the basic explanation which was used by your teachers in school or in your coaching to explain the solution of this particular situation. So, now from here what we can say, F equilibrium of Q and Q should be negative. Fine. So, let me allow to write it down as here itself. I want to remain close to the question, that is why I am writing over here, otherwise I was supposed to take some space present over there. So, over here what I can say, for equilibrium of capital Q, fine, Q should be negative, Q should be negative. For equilibrium of Q, small q should be negative, that is 1 over 4 pi epsilon naught Q over, let us say, r square. R is the distance, fine, let us say r square is equal to 1 over 4 pi epsilon naught. This is one mistake type of thing, because initially I declared I will write down k, but no problem. I do not like writing again and again these long expressions. Q and r by 2 whole square, because it is given in the problem itself that it is at midpoint. Fine. So, cancel, cancel, q, q. Ultimately, when you solve, you will get q is equal to capital Q by 4, and that too with minus sign. Therefore, small q is equal to minus q by 4. Fine. So, now if you try to check, then the answer is in front of your eyes itself. It is saying I am your correct answer. Simple. So, now as such nothing is difficult till now, at least. I proved my words that getting into IIT is not a difficult task, it is very simple. Fine. Obviously, let me allow to move for the next problem, and for that I am cleaning the board over here. Fine. So, let us move on to the question number 4. Such type of problems are asked in JEE just to create some hurdle in your thinking. Why? Because long statements, you have to visualize so many things. So, ultimately it is going to create some sort of problem. Listen, two equal negative charges minus q are fixed at point 0 comma minus a. So, the very first thing that you will have to do, you will have to design a coordinate system. Fine. And 0 comma a on y axis. Let me allow at least to translate this much line. Fine. And that I will do over here itself. This is x axis, this is y axis, and this is z axis. Now, I am going out of this. Let us try to plot the points. Two equal negative charges minus q charges are fixed at point 0 comma minus a. Oh my god, 0 comma minus a means somewhere over here. Fine. Let us say, let us try to make this diagram more simple. And I hope now it is going easier for you. X, y, z, obviously this is negative y. So, 0 comma minus a, let us say over here charge minus q is placed. Fine. Another charge is at 0 comma a, very good. So, this is minus q. Now, do not get confused, they are not going to form a dipole, reason being both are negative. If one is positive, one is negative, then that story is different. A positive charge capital Q is released from rest at point 2a comma 0. So, 2a comma 0 means let us say from somewhere over here. A positive charge Q is released. Release means initially it was rest, no force is applied, simply you put it over here. So, what will happen? Obviously, this charge will apply a force of attraction, negative, positive. Think, this charge will apply a force of attraction, negative, positive. So, ultimately the tendency of this capital Q is anyway will try to move towards the origin. Fine. Obviously, it will not go in this direction, not in this direction, not in this direction, and so on and so forth. The charge Q will do what? Fine. Execute simple harmonic motion, move to origin, remain at rest, move to infinity, execute oscillatory motion, and so on and so forth. So many options are given, very simple. So, now let us allow me to explain the solution of this problem. Over here, this charge, first actually in this particular question, this question is from electrostats, but they used your concepts of simple harmonic motion class 11th. So, it is again a beautiful part of JEE advanced exam pattern questions, because one question may contain 2 or 3 concepts from different chapters. So, motion will be SHM, motion will be SHM only only if Q is released, only if Q is released from, motion will be SHM, simple harmonic motion, only if Q is released from a point not very far from the origin on x-axis. Entire statement I provided for your thinking. Fine. So over here the situation is not like this. This charge has been released from a long distance to A. So therefore this charge is not going to execute SHM. Second option, move to origin, remain at rest. No. Why it will remain at rest? Because it has some force which is attracting over here, so up to some extent it is going to move in this direction because of inertia. Move to infinity, not possible, again they will pull and so on. So only the correct option is that it execute auxiliary but not SHM. So this question is so simple that I think even a class 11th student can solve it. So again it's a proof that IIT JEE Advanced exam is very simple. It is different thing that out of 15 lakhs only 7,000 will get admission. So you can think how simple this exam is. Okay. Now let's move ahead for next problem. And deliberately I'm devoting good time to give you a feeling that there is no need of feeling any type of panic about these exams. Here is your fifth question. Assume an electric field this much exists in space, then potential difference where E is the potential at origin and VA is the potential at x is equal to 2. Students, this is the very first formula that you learned during the second chapter of class 12 and the question is based upon that only. Fine. So let's discuss what exactly the solution over here. As VA minus VO, because it is given over here, so there is no point of explaining or drawing any diagram, is nothing but potential difference dV is equal to minus E dx. Is there anything new in this formula? Not at all. Very simple formula. So from here what we can say, dV is like V naught to VA and that is going to be this value. So minus, what is the value of E? 30x square I cap. So let me allow to put it over here with this limit, that is x is equal to 2, 0 to 2. Integration limit even given in the problem, 30x square dx. And if you are preparing for JEE exam, obviously integration is going to be very simple. So from here finally V is equal to minus 80 this joule. So this is C is the correct option. Now students, over here we would like to close this discussion because in some next point we will discuss further some more questions. Fine. So here I would like to say thanks to all of you. Keep watching these videos. In future definitely you will get some more questions in consequence moving ahead from this. Thanks a lot.